Hello code artists, welcome to lesson 4 of our introductory programming logic with JavaScript course. This lesson is all about selection logic, so if, else. Going to throw some other stuff in there for good measure. So go ahead and stop the video please and read the requirements right here and then we'll continue. I'll wait. Okay, welcome back. I assumed you've read what the requirements are, so as you know, the best thing to do is to figure out what our variables and constants are, and so that allows us to kind of have the program write itself once we figure that out. So going through here and looking at this, I see that I'm going to have customer ID will be a variable, dog age will be a variable, dog weight will be a variable, service type is probably going to be a variable, and then we need to calculate the total bill. We're also going to have dog name and dog breed, so those are going to be string variables, where the other ones that I mentioned are going to be numeric variables. And I am going to have one Boolean variable, but I'm going to make it numeric, and it's the continue response, so 0 for no, 1 for yes when I ask the question for the users, would you like to continue? So let me just go ahead and put in my global variables right now so you can see them, and notice they're all gray because, or excuse me, they're gray and they're squiggly line because we haven't used them yet. But you're probably asking yourself, well, what about all these constants right here, because they did give us dollar amounts? Well, you're right, but if you remember back to our 10 commandments, we typically want to prefer local over global, and these don't really need to be globally accessible. They can be, but it will be better for programming practices to keep these locally scoped inside of a function, and so you're going to see how I do that. So since I have all of these global variables right here, I'm going to need a mutator method for each one of them, except for, well, no, we're just gonna go with what I just said. So I'm going to start popping in my mutator methods, but I'm not going to start with the first one. I'm going to start with customer ID. Let's take a look at that. So I'm going to Control C off screen, come in and leave room for another one that we're going to put in, and we're going to put customer ID. So if you remember, the requirements down here was to randomly generate a customer ID, and as you see right here, this is probably the simplest way to generate a random ID in JavaScript. So I use this math class that's in the language and its floor method, and I pass to it the math.random method and multiply it by 20, and I add 1. If I didn't do the plus 1 right here, it would be 0 to 19 would be the random number that was generated, but since I do the plus 1, it makes it 1 to 20. If I wanted 0 to 20, for example, I would get rid of the plus 1 and make this 21, and that would give me a random number from 0 to 21. And so now the customer ID has been assigned a random number anywhere between 1 and 20. This is also on our reference, or quick reference card for JavaScript, so this is super easy. This is basically the formula that you'll use the most, like if you're making a dice roller or a game where there's different chances to do. This is the simplest way to do it in JavaScript. Okay, so that satisfies the requirement of customer ID. You see that they start to light up. The little green squiggly means it thinks it's a typo, so not a big deal. Alright, what's the next one on our list? We've got dog name. I'm going to come down here, Control C, Control V, paste it in. Just like you've seen before in previous videos, I'm just simply using prompt.question, which is up here for this library that we imported. And you'll note when I started this video, I already had the basic skeleton of the code created because I used a template. Okay, so that's just a standard setting the dog name. And what's the next one that we're going to do? Dog breed. Control C, Control V. There's dog breed, same thing as dog name. Notice we're just kind of going through right here and adding the mutator methods for those variables. And that's kind of what I mean when I say once you figure out what your variables are, the code kind of starts to write itself. and then we'll go back in and fill in the main method and call these methods in the order that we want. Alright, next one down that we're looking at is the dog age, and this one's going to be interesting because this is where I start to show you some validation. Control C, Control V. Alright, so what we've got right here is a method where we can validate because we've got a max age that we want, and the program did not give us the requirement for a max age of a dog, but I went ahead and Googled to see what like the longest lived dog was, and it was like 29, so I put 30 on here. So we're saying that you really shouldn't have a dog older than 30 years old. If you put that in, then it's probably a typo. And for the minimum dog age, you might be saying, well, that's a magic number and we shouldn't have magic numbers, but this is very obvious, and I didn't want to create a whole separate constant for min age because we know what this means right here. If the dog's age is less than 1, that means they put a typo in. Alright, so dog age, we ask them what it is. Then since these are read sequentially, the very next thing that happens after the semicolon is I come down to this if statement. And this is your first look at an if statement, and this is a essentially a single alternative if, meaning if this condition right here is true, then do this. Otherwise, there's no else if or else. Just ignore this right here and keep going. So this is saying if dog age that they enter is less than 1, or, and that's your Boolean or operator, 2 pipes, which is the key right above the enter key, same as the backslash key, or dog age, and notice I have to do the full test on both sides. I do the full test dog age less than 1 or dog age greater than max age. I can't do dog age less than 1 or greater than max age. I need the full test with dog age in here. So if dog age is less than 1, so they put 0 in for their dog age, or they put 31 in for their dog age, I give them an error message. I'm sorry, that's an incorrect age. Please try again. And I do a tail recursive call, and I call myself again, and I run this, and it will keep doing that until they enter proper information. So that is a way that you can validate to ensure that what they're putting in is correct. It's just the very beginnings. We get into a lot more in depth with the validation and sanitation and distillation as we go further in the videos. So that's the dog age. So you see we're filling them in. So probably the next one will be dog weight if I had to guess as I scroll down, and it is. So I'm going to Control C, come down here and paste it in. Okay, so for dog weight, we've got max weight of 300 and min weight of 3. And again, this wasn't given to us, but I went and Googled kind of like what the heaviest dog ever was. It was actually kind of eye-opening. There was some fakeness out there about a Mastiff or whatever, but really the biggest thing that I could see that ever existed was just under 300 pounds. So we'll give them the benefit of the doubt and say 300. And the min weight, if you've got a dog smaller than 3 pounds, probably not a dog. You're probably looking at a hamster or something that you've misidentified as a dog. So again, that wasn't given, but I went ahead and figured that out just for, you know, for good values. Anyway, they put the dog weight in. If the dog weight is less than the min weight, or if the dog weight was greater than the max weight, same thing as we did up above. Sorry, that's an incorrect weight, and I tail recursively call myself right here. And the tail recursion has to do with this return statement and me calling my same method from within myself again. And this is something that's actually I've found kind of difficulty understanding the different things on the internet about tail recursion and recursion in general. And in the old days of teaching this class, I always said limit your recursion drastically because you could be affected by stack overflows. And what that means is, so you open up this memory block right here on the computer in RAM, and you start doing this method right here, and if you get down to in here and you call the same method again, well, you never hit this close curly brace to reclaim this memory space. And if you keep doing that, you keep increasing the amount of memory that you're opening up in order to do this, and if you never hit this curly brace, you never reclaim any of that. Apparently, with the new version of JavaScript that we're using for this class, the ES6 version, this return statement right here used with the recursion call is tail call optimized. And I'm still a little fuzzy on whether or not the browsers support that or if Node.js supports that, but I'm being told in some of the forums that this is perfectly acceptable nowadays, so we'll go with it. Alright, so the next one down is the service type. So we're up to these. Now we just need to see if they want a basic, deluxe, or turbo groom, and then we only have a couple more to do. So we'll come down here to the service type, and I tried to get a little clever with this one and copy it and paste it in. This will be your first example of switch case logic, so I'm going to paste it in. So what I did to get fancy with this is I did a little technique because I knew I wanted them to choose either basic groom as 1, deluxe groom as 2, or turbo groom as 3. But I also wanted that to be the price multiplier, because if you look down here, the cost is 10, 20, and 30. So 1, 2, and 3. So all I did was I simply said if they chose 1, I made the service type times the multiplier. So what this is shorthand right here for service type, which let's say they did 1, is equal to service type times the multiplier, so 10, 20, or 30, because the multiplier is 10. Alright, so the way the switch logic works is, and this is best if you have hard and fast values here that you want to use, not if you have ranges like we did up here for if statements. So we say if the service type, essentially switch, if the service type is 10, then do this. And this is the exact syntax for it with the colon and the break statement down there. If you don't want the switch to break out right here up above like this, but you want it to keep cascading down, then you would omit the break statement right here. But this is saying that if this is the truth, then go ahead and stop the switch logic. So if they put in 10, then I just simply console log wash and clip. Got it. But notice I've also set the service type value up here so that, or I've assigned it the value up here. 20, 30, etc. You get the idea. And then there's a default one. So if they didn't choose anything up here as the correct value, then this is how I'm validating down here. I say incorrect choice, please try again, and I do my tail recursive call, which comes back up here and runs it again. So that's how I handled that. And next up we should have, let's calculate the total bill. And this is where you're going to see a huge amount of constants in here. Come down here, Control C, Control V. Alright, down here with all of our constants, these were all the things up above where we said the dog weights and then what the fees are. And I initialize our total bill right now to be 0. I just set it to 0 before I come in here and do all of this. So I say if dog weight is greater than 0, which is what we're hoping for. We should have, if we've gotten down to this far and the dog weight is still not correct, we've got a problem, excuse me. But if dog weight is greater than 0, then I come down here inside of this nested if statement, and that was the only reason I did this, was so I could show you nested ifs. Then if dog weight is greater than 0 and dog weight is less than small dog weight, so it has to be, both of these statements have to be true. That's what and means. Or means either or have to be true. This one, both of them have to be true. So the dog weight does have to be greater than 0, and the dog weight has to be less than small dog weight, which is, where are we, 15 pounds, then I say the total bill is equal to small dog fee plus dog age plus service type. And so this was the 10, 20, or 30. This is simply their age of the dog we add to the bill. So if the dog's 7, it's $7. Alright, then we come down and here's our cascading if statements. Else if the dog weight is less than medium dog weight, then I do, and total bill is equal to medium, etc. Then if it's less than large dog weight, then I have a default else here. Meaning if none of these were true right here, then obviously this must be the one that's true. That's what the else means. I don't need to do a last test, and that's something that a lot of beginning programmers do, is they accidentally want to do the last test here, but you don't need to. So if you follow the cascading waterfall of selection logic, because a lot of learning resources will tell you that if statements are kind of expensive because of the way compilers deal with branching, and these are all different types of branches, you want to put your highest likelihood of truthiness at the top so you can exit these as fast as you can. But another way that you can make these better is by not doing a final test here. So if this wasn't true and this wasn't true and this wasn't true, then this must be true. You don't need to do a test. You just simply use an else statement and say total bill is equal to jumbo dog fee plus dog age plus service type. So that calculates the total bill, and that essentially got us every single variable right there except for continue response. So we're going to come back up and add continue response right in here. Alright. Control C, Control V, put the method in to mutate continue response. So here it is. So for continue response, I come in and I say if continue response is equal to 1 or continue response is equal to 0, I set it to whatever they put in, and notice I surround it with this number class so that I make sure that it's going to be numeric. If continue response is not equal to, and that's what this means right here, not equal to 0, and continue response is not equal to 1, they type something in incorrectly, I validate it right there, and I output, well, whatever they put in is an incorrect value, please try again. I set continue response to 1 automatically, and then I recursively call this method again right here. So since I call it again and I set it to 1 right here, I ask them, do you want to continue? Yes or no. 0 for no, 1 for yes. And once they finally put something in, then I exit out, because this if statement right here has to be true to continue. But why is there an else right here? Well, because in the main method you're going to see the first time I call this method right here, it's not going to be equal to 1 or 0 the very first time. So the first time I run it, I set it to 1, so when they first run the program they don't get prompted for do you want to continue or not, it just runs it automatically. So let's take a look at what that looks like in the main method as I put in all of the functionality for the main method here. We'll paste it in. Alright, so we hit the dispatch method. The first thing I say is if continue response not equal to 0 and continue response not equal to 1, set continue response. So right now its value is undefined. So it's going to come down here and it's going to say, well, it's not equal to 1 and it's not equal to 0. Excuse me, I had a little something in my throat there. So it's going to come down and set it to 1. And then since it sets it to 1 right here, when I hit this curly brace, it's going to come down and it says if continue response is equal to 1, well, now it's going to call all of our methods in order. And then it's going to recursively call main again, and since it now is 0 or 1, it's going to skip that and come down and see what we set it to right above this return call to main. So if it was set to 0, it doesn't run any of these things right here. And then it's going to print goodbye and print total bill. Now I didn't put those methods in, so I'm going to come over here and just grab those really quick. Those are just two little simple methods here that just have print statements. Control C, come down here to the bottom, and we'll just drop them in down here at the bottom. Control V. So there's the print total bill, and at the end we just print goodbye. And then the print total bill, I'd like to point out that we're using the template literals with a new line, a tab, the value of dog's name, the value of total bill, and notice that I used an escape character so I could actually get a $sign in front of total bill, and then the value that's stored in customer ID will be printed out there as well. Okay, so that pretty much covers everything to do with selection logic, Boolean, random, if else, switch case, we covered all that. The return statements we used with the methods, return service type to do the tail recursive calls. We talked about validation, and we talked about random. Okay, that's everything for lesson 4. Thank you so much for watching.